Okay, so I'm making this video for a friend that wants to learn a little bit more about injection molding and what you have to do when you're designing a part to incorporate for the designs of injection molding. There are several concepts you have to have that are not the same as, let's say, CNCing or fabricating from hand. Okay? When I design something at Jet, I usually design something in the core, functional and working, and then I hand it to my production engineer. Hold on a second. My production engineer usually does these adjustments. In the future, I'm going to do these adjustments. But there's just certain things you have to know when you're molding a part. Now let's take this dual strike right here, okay? If you look at it, and if you look real carefully, look at the surfaces of this molded part, and you'll notice a very slight return. In other words, it's slanted. Both these sides are slanted very slightly, okay? And they do not go in like this to pull out of the mold this way. If, for example, you inject plastic in a mold, okay, and you were to put designs that go like this, your molds won't release. Basically, you will lock the plastic in the mold, and you won't need like a Dremel tool or to melt the plastic out or something like that. Right. Now this is really interesting. So you have to have a return to do it. Now, when you see parts, let's say different, maybe these rails. Well, shit, how do they do that? Well, you can see very easily right here. You can see right on top of this, get a dual strike, get the same blaster, and you'll see little bead marks. These bead marks are because when you put a mold intersection on something, it will never be perfect and will never make like a perfect Class A finish. You will always see these little marks. Yes, it's still one piece of plastic, but it alludes to the fact that it's a multi-piece mold. On a dual strike, you have one piece here for your rail, here and here. Basically, your shell is a 3-piece mold. One for this return here, and one for this side, one for this side. That's how a dual strike shell on the outside is made. And I want to just focus just on the shell today. I'm not going to elaborate on other parts because other parts have other things. But if you study, look at your blasters and look for these little marks. And sometimes they're not easy to see because they try to put them by the edge, just like Hasbro tried to do. They tried to put it on this little edge here, but they went a little over because, well, they're lazy. I mean, somebody could have easily made this tooling so it stops right here and made it look precise and hide this bead mark. That's right here. Do you see it? You see it? You can see it in the light. There it is. See that? That little distortion right there. Yep. That indicates a third piece of a mold. Anytime, you must have two pieces and that they clear. When you're designing, you have to think of what your mold is going to look like. Is it going to be a 2-piece mold, a 3-piece mold? And put in mind, when you're talking about injection molding, you're talking about a back side too, which means this one has a front side, a rear side that puts in all your ribs, and a top side for this return. So that's a 3-piece mold, okay? Which means each one of these is the 3-piece mold. Kind of a waste of a 3-piece mold, really, because you have to you just have to put a third piece just for this rail. That's terrible. At least with a Pictionary rail, you can go 2-piece. Like if I had this right here, and this was Pictionary rail, and didn't have this little return, that would be 2-piece, because then I could just take half my 10mm rail, half my 10mm rail, and boom, there it is. But let's not get off the subject. So one thing you have to understand is draft. It means that no matter what, you cannot have a part that's going straight into mold. Imagine it's a flat mold that does this. So when the mold is in here, you can't pull it out of the mold. It has to be like this. You don't have to go too aggressive on the draft, okay? Molds are given release agents such as waxes, oils, such and such. But you do have to be aware of it. Number two, you must be aware of the shrinkage of the material. For example, if you have a big glob of plastic, okay, what will happen is that your plastic goes in, it's many hundreds of degrees. And in a very short period of time, it's being cooled to near room temperature. Maybe 90, 100 degrees, I'd say, before it goes out of the mold. Okay, I think about 80. I think somebody once told me that 85 is a good temperature because the plastic still pulls because it's somewhat soft. And and it's manageable. I've heard of some people doing 100, 120, but the hotter your ejection temperature pulling the part out is, the more you're going to have warpage. Well, also thick areas, because you're going from 700 degrees to near room temperature, relatively cool. You're going to have, if you have large amounts of material, you're going to have shrinkage, and the shrinkage will show in these little shrinkage marks. It's not good. It's not good. Because if these are things that need a lot of dimensional stability, and interlocking breach is one of those places, then it's going to shrink. So at most, on a shell, you want 2 millimeters. 2 millimeters thick plastic. Okay. Your third problem is your injection ports. Basically, every part, let's see if we can find our injection port on here. I'm looking. There it is. Your injection port is right here. See that? See that little divot right there? Little tab? That's an injection port. Right here, this is where super hot ABS plastic goes in between the two molds that are sealed, and they spread all around the part. You have to account for the fact that as this is filling, it's going to cool down and start getting hard. Meaning, you do not want this too big. Maybe you need more than one injection port. Maybe you need other things. Now, when it comes to designing in SOLIDWORKS, don't worry about it. Just put in mind that you don't have to worry about where the injection ports are. Your injection molder will most likely handle that. But you yourself have to understand that this is going to be 2 molds, actually 3 over here, and the plastic is going to run through here like a river. And if that river has such constraints that it's just, you can't do it in one bang, then you're going to have problems where your plastic is not going to reach certain places. You're going to have problems where one part of it will be cool, and another part of it will be hot because one part of it got the plastic right away, and the other part of it is hot, and that will cause it to bend and warp. Okay? So you have to keep this in mind. You don't want some crazy design where all of a sudden it's easy to put plastic here, but back here it's really hard because you have all these weird ribs and stuff and everything. That's more than just your normal Nerf plaster. So you don't want to overdo it. Okay? When you're designing shells, you want to focus on internal structure. Okay? You want to focus on basically what do you need to support your motors, support your plunger tubes, support your barrels, support your screw joints. Okay. What do you need to do that? What's a minimalist you can do with at most 2 millimeter ribs? And 2 millimeter ribs is really strong for injection molding. Okay, it's really strong. Some people go like 3/4 of a millimeter when they do this stuff, and the reason is very simple. So you don't have all these